So we are moving on to section 8.6 today. We've been looking at systems of inequalities. We're going to look at what we can do with those systems today. Our objectives are that you will be able to write what's called an objective function describing a quantity that must be maximized or minimized. You'll be able to use inequalities to describe the limitations in a situation. We call those the constraints. And you'll be able to use something called linear programming to solve these. We are going to take this in baby steps. So today you will be given the objective function and the constraints. We're just going to look at what we do with those. Tomorrow we will move on to, can you come up with the objective function and the constraints based on the word problem? Okay? So we have been graphing constraints. We haven't called them that. We just said they were a system of inequalities. But in terms of a business, pretend you're a business and there are things that limit you. All right? Maybe your building is only so big, so you have limited storage. Maybe you have limited funds. Maybe you have a limit to the number of hours your employees can work. All right? Things like that. There are constraints that you have. You have to work within those constraints to try to maximize your profit or minimize your costs. Okay? So a business would take all of their constraints and they would figure out what is the optimum production we should do so that we can get our maximum profit. Okay? So the objective function is an algebraic expression in two or more variables describing a quantity that must be maximized or minimized. Again, it's very typical. You're trying to maximize profit or minimize cost. The constraints are all of those inequalities that refer to what we are limited to. And when we were graphing our inequalities in the last few days, I said it's important that you draw your lines accurately because we are going to need to find these vertices. Okay? Because all of your maximums and minimums are going to occur at one of those points. Even though every point in this shaded region is a solution, it fits all of our constraints, your max and mins will only occur at one of the corners. All right, so those are the only points we're going to be checking. So our steps. Our first step is to graph the system of inequalities, those constraints. Next, we're going to find the vertices of that overlapping region. We often refer to it as the feasible region. All right, those are all of the points that work within our constraints. So we're going to graph them, we're going to find the vertices of the overlapping area, and then we're going to plug those vertices into our objective function to figure out our max and mins. Okay, I'm going to pause the video, let you write those down. So our first example, it says find the maximum and minimum values for the objective function f equals 5x plus 8y. Again, tomorrow you're going to be coming up with that objective function. Today you're going to be given it. Okay? We have 4 constraints, but we talked yesterday, what do those bottom 2 mean? So we need x's to be 0 or higher, we need y's to be 0 or higher. Where is that on our graph? Quadrant 1. All right, so again, if you identify that you know that is quadrant 1, you don't necessarily have to shade that in. Okay? For the green one, it is in standard form, so we're going to make our t-chart again. Putting in 0 for x, we get what for y? Okay, putting in 0 for y, we get 5. Now, my recommendation is to make all of your t-charts first so that you can decide, do I need to rescale my axes or not? Okay, so let's go ahead and do the red one as well. If we put a 0 in for x, we end up with 14 divided by 3. What does that come out to be? 14 divided by 3. Okay, 4 2/3. 15/3 would be 5, so we're just under 5. All right, put a 0 in for y, we get what? 7. All right, so take a minute and plot those points. We can go by ones on our graph. All right, go ahead and plot the points and draw your lines in. All right, once your lines are drawn, you need to decide which side you shade. So remember how we test a point? If I put 0, 0 in here, right, I get 0 has to be less than or equal to 10. Is that a true statement? So the origin works. So I'm shading underneath the green line. Okay. For the red line, does the origin work? Okay, so we're shading underneath as well. Now remember, we have to be in quadrant 1. So we do have a cutoff here and here as well. Does that make sense? So if we are underneath our lines, but we're still within quadrant 1, we are looking at this section in here. Okay. Our next step is that we have to find the vertices of that. Okay. So, first point, the origin. Would you agree that that is one of the corners of my shaded area? Okay. This point up here is a point that we actually plotted, right? So we know the exact coordinates. What are those? What was it? 0 and 4 2/3? I'm going to write that as 14/3 in its original form first. It's going to be easier to plug that in than to plug in a mixed number. Okay. How about this point here? That's another corner. What's the coordinates? This one here? 5 0? Okay. Now, the last point is where the green and the red lines actually intersected. Can you tell from your graph the coordinates of that point? We have a point at 5 0. So 5 2 would mean that is a vertical section. Is it vertical? It shouldn't be. It should be slanted a little bit. So it's not 5 2, but it is 4 2. Okay. Now, I'm going to show you how to check that, because it would be very common for you to graph a system of inequalities and have the lines intersect not at a nice corner, especially if your tick marks are going by something other than ones. All right, say your tick marks are going by tens, and it's going to intersect in the middle of one of those grids. Okay, you have to know how to find it. The two lines that are intersecting came from these two inequalities. So I want you to picture what we did at the very beginning of this chapter when we solved just a regular system of two equations, right? We found where those two lines intersected. How could we solve that system? Okay, we could get rid of the x's if we made one of them negative. So let's multiply the top one by a -1. What do we get now when we add them together? And if 2y equals 4, then y has to be 2, which fits what we had. Okay. If we plug a 2 back in for y, we've got 2x plus 2 equals 10. Subtracting the 2, we get 2x equaling 8, which means x would have to be 4. So we do have the right point. Do you have to do that process for every single question? Not necessarily. If you're pretty confident in what the point is, could you just go back and plug it in to these two inequalities? In other words, could we put a 4 here and a 2 here, and a 4 here and a 2 here, and see if they work? If we can prove that they work in both of those statements, then we know we have the right point. Okay? So, all the more reason it's really important for you to draw your lines accurately. All right. Then the last step, we've graphed our inequalities, we've found our vertices. Our last step is to plug them into our objective function. Right? And our objective function in this case was 5x plus 8y. All right, that's what they gave me up here. So what I'm going to do is I'm going to plug all 4 of those coordinates into my function to see what kind of value I get out. So in the first one, we're substituting 0 for x and 0 for y, which gives us a total of, all right, plugging our second one in. We're still putting a 0 in for x, but this time we're putting in 14/3 for y. Take 8 times 14 and divide by 3. What do you get? Eight times 14 divided by 3. What do we get? What'd you get? Okay. So 37 1/3. All right. Plugging our next point in. We're going to put a 5 in for x. This time we're putting a 0 in for y. We get a total of 25. And our last point, we get a total of 36. Now, the order that you put these vertices in over here doesn't matter. All right? But you have to try them all, because we said that our max and mins are going to occur at a vertex point. So, looking at the values we get out, what's my highest value? Okay, and then the lowest? 0. So I've got my max and mins figured out. Okay, so I would say I have a maximum of 37 1/3 at the point 0, 14/3. You're always going to give me the coordinates where it happens. Tomorrow there will be a context to what those x and y's stand for. It will make a little more sense. Minimum of 0, and it happened at the origin. Okay. All right, I want you guys to look at the second question. Talk at your tables. Can you make a T-chart and get your graph drawn? All right, what do we get for our intercepts for the first inequality? 2x plus 5y is less than or equal to 50. If we put a 0 in for x, we get 10, and a 0 in for y. All right, for our red one, putting a 0 in for x, 20, and a 0 in for y. We have 100 divided by 7. What does that come out to be? Okay. Now, looking at all of those values, the largest one I see is 25, but my grid only goes up to 20. So I am going to have to rescale it. All right, so I'm going to go by 2s. Make sure you indicate that on your axes. Couple suggestions. You want to make your graph as big as you can make it. All right, you don't want to scale it down unless you have to. If your graph is too small, it's going to be really hard to find the vertices. Okay? All right, so starting with our green one, we need a 0, 10. So we're up here at the 5th tick mark, going by 2s, and then 25. and then draw your line. Go ahead and do the red one as well. All right. In terms of shading, do we want to shade towards the origin or away from the origin? Towards. So the origin works in both of our inequalities? All right. So shading towards the origin. And then again, remember, this means quadrant 1. All right. So we're underneath each line. We're still in quadrant 1. So we're looking at this part in here. All right. Go ahead and find the vertices of that section. All right, so we next have to figure out the vertices. We have one at 0, 0. We have one here. We plotted that one. And remember, our tick marks are going by 2, so that's actually the ordered pair 0, 10. We have a point here that we plotted. It had coordinates, what? Which one was that? The 14.3? Okay. I'm going to put it back, instead of 14.3, I'm going to put it back as 100/7. All right. And then where do they intersect? If we are counting our tick marks by 2s, they intersect at 10/6. Okay. Now, always double check that point. The ones on the axes you should be pretty clear with because they're ones you actually plotted. But where the 2 lines intersect, you do want to double check that that's the right point. So you should be putting 10/6 in for your XY and making sure that it makes both of those statements true. Okay? All right, then we plug them into our objective function. We have f equals 7x plus 6y. All right, plugging 0, 0 in, we end up with 0 for that one. Now we're plugging in 0, 10. We should get 60. Okay. This time we're plugging in 100/7 and 0. The 7s here are going to cancel out, so we just get 100. And our last one, we're plugging in a 10/6 as our ordered pair. So we have 70 plus 36 would be 106. All right, so which of those gets me the highest value? The 10/6. So my maximum is 106. And remember, you're always going to say max value at, and then the ordered pair where it happens. Okay, so at the point 10/6. My minimum is what? Minimum is 0, and it happens at the origin. Okay? So today you're just practicing. Can you graph all of your constraints and find that shaded area? Can you find the vertices? Can you test them in the objective function? Tomorrow we'll move to where you actually create the constraints in the objective function. All right, so homework tonight, you have page 856. You're doing 6 through 14 evens. That means you have 5 problems to do. Okay, at your tables there should be 1 sheet of graph paper for each of you. Space it out so you can get 5 graphs on there. Okay, always make your T-charts before you start graphing so you can tell what kind of scale you need.